Algebraic Reasoning Chapter 2.1, exercise 13 through 20. This exercise set has to do with transformations of functions and specifically linear functions. For questions 13-16, identify the domain, range, x-intercept, and y-intercept of a linear function described by the equation of the graph. Write the domain and range in set builder notation. So let's go ahead and look at this function, and we have the function here in equation form and its graph below. And we have f(x) equals 1/4 quantity x plus 8. So if we distribute this 1/4 to that x and that 8 inside the parentheses, we have 1/4 times x plus 1/4 times 8, and it's going to simply be 1/4 x, and then 1/4 times 8 is going to be plus 2. So we can see that we do have a y-intercept of 2. So I'll put y-intercept, comma, I'll put the coordinate pair form, 0, 2. Okay. An x-intercept down here according to the graph looks to be -8. And I'll put the coordinate pair -8, 0. And we'll just go ahead and verify that. If we take this 1/4 x plus 2 and set that equal to 0, so 0 equals 1/4 x plus 2. If we subtract 2 from both sides of the equation, we have -2 is equal to 1/4 x. And if we multiply both sides of this equation by 4, 4 on the right side, 4 on the left side, -2 times 4, we have -8 equals x. So that confirms our answer up above. Now this is a polynomial function, and more specifically a linear polynomial function. And it says write the domain and range in set builder notation. Now I'm not much of a big fan of set builder notation, not that I don't think it has value, but it's just that we're going to be going into interval notation. Interval notation is going to be more commonly used, but I'm going to go ahead and use set builder notation. We will say set builder notation. I'm going to put parentheses, not parentheses, brackets. We're going to have x, and this vertical line segment x such that that vertical line segment is such that x is an element, and there's that little sideways e, of element of all real numbers. I'm going to write this script R here, okay? And yeah, it's kind of, I don't know how to do that. And it's x, that's going to be our domain. I'll put D, colon, and our range is going to be the same, except we're going to be using, I want to use y, but I'm going to use f of x instead, since we are in function notation here. So we'll say f of x is an element of such that f of x is an element of all real numbers. So that double script R thing. And I think I'm just going to leave that as the example here is going to be, and then of course in interval notation you have domain, greater than negative infinity, less than infinity, range, greater than negative infinity, less than infinity. But according to the specifications here, there we have our x and y intercepts, and here we have our domain and range in set builder notation. Okay, next, we're going to go over next on problem 15. By the way, I'm going to do 15, 17, and 19. Okay, same instructions here, but we have this f of x equals negative 2 times negative 1/2 x plus 3. So we're going to distribute just as we did before. And we have negative 2 times negative 1/2 x. And then we have plus, I'm going to say negative 2 times 3, distributing that negative 2 to this 3, and the outside plus 5. Now I'm going to work over to the right. This negative 2 times negative 1/2 is going to cancel out to be just 1. So that'll be 1x. And then we're going to have negative 2 times 3 is negative 6. Negative 6 plus 5 is going to be minus 1. So our y-intercept is going to be the point 0, negative 1. And our x-intercept is going to be the point 1, 0. And again, we can take this f of x equals x minus 1, so we say 0 equals x minus 1. Add 1 to both sides, we have 1 is equal to x, which confirms our x-intercept up here. And in set builder notation, okay, our domain set builder notation is going to be x such that x is an element of all real numbers, and then our range is going to be f of x such that f of x is an element of all real numbers. And those would be our answers to problem number 15. Okay, next we're going to look at problem 17. And in this set, in questions 17 to 20, identify the domain, range, x-intercept, and y-intercept linear function described by the equation and the table. Write the domain and range as intervals. Well, we're given an equation here, and we can see that being a polynomial function, polynomial functions can have a limitation to the range, but being a linear polynomial function, we're going to have our domain of this as all real numbers, and our range is going to be all real numbers. Now, a polynomial function can have a limitation to its range, but not to its domain. And let's see here. Domain range. We do not see anything here that would give us an x-intercept and y-intercept based on the table alone. So what I want to do is take this, I'm going to put f of x over here to the right, equals negative 2/5 quantity x plus 8. And with that, we're going to distribute this negative 2/5 to the items inside parentheses. And working below, we have f of x is equal to negative 2/5 x. And we have minus 2/5 times 8. What we're going to get for that is negative 2/5 x, and then we're going to have negative 16 over 5, so minus 16/5. Is that right? Yeah, and I think that's about as close as we can get. So say f of x is equal to negative 2/5 x minus 16/5. So our y-intercept is going to be the coordinate pair 0, negative 16/5. I think that's going to be negative 3.2. And as you can see here in the table, we have negative 3.2 occurs between negative 2 and negative 4. And then that would correspond to that 0 between x equals negative 3 and x equals 2 on the left side of the table. So that makes sense. Now with this function here, I'm going to set that equal to 0. So if we say f of x equals 0, 0 equals negative 2/5 x minus 16/5. And if we add 16/5 to both sides of this equation, we have a cancellation here, and I'm going to continue to the right. Not going to have a lot of room. We have 0 equals, now we added 16/5. Pay attention. 16/5 is equal to negative 2/5 x. And now what I'm going to do is I have negative 2/5 x on the right side. To isolate x, I'm going to multiply by its reciprocal, which is going to be negative 5/2. Okay, and doing the same thing to both sides, negative 5/2 on the left side, the right side. So this negative 2/5 times negative 5/2 cancels out. So on the right side, we have x. It's going to be our x-intercept. And the left side, we have negative 5 times 16, which is going to be negative 80. Over, we multiply these denominators together, we have 16/5 times 5 times 2, so 10. So we have x negative 80 divided by 10 is going to be negative 8. So x equals negative 8. So where y equals 0, we're going to have x equals negative 8. And from the table, does that make sense? Kind of does, because as we see y coming up approaching 2, 0, we have x getting smaller and smaller from -3 to -6, and eventually -8, or y equals 0. So I'm going to put up here y, x-intercept is going to be the point -8, 0. And that gives us our domain and range up here. And we have our y-intercept and x-intercept down here, kind of to the lower right. Okay, the next one I'm going to do in this video lesson is number 19. And we're going to do the same thing we did in number 17. We don't see an x or y-intercept clearly visible from the table because we don't see any zeros here. A 0 would give us that. We can kind of estimate what they would be. We know we're going to have a y-intercept somewhere between -12 and 12. Let's work this out. We distribute to the right. We have f(x) equals -3 times 2x, so -3 times 2x, and then -3 times 5 is going to be -15 plus 9. And then continuing to the right, we're going to have -6x, and then we have -15 plus 9 will be -6. So what is domain and range as intervals? Well, our domain is going to be all real numbers, interval notation greater than -infinity, less than infinity. Our range is going to be the same, greater than -infinity, less than infinity. Okay, we've got the domain range out of the way. Anyway, we have the function now simplified in slope-intercept form as f of x equals -6x minus 6. So our y-intercept is going to be -6 because this is slope-intercept form y fx equals mx plus b. So our y-intercept is going to be the 0.0, -6. And what is our x-intercept going to be? Well, to do that, if we set this equation equal to fx equal to 0, 0 equals -6x minus 6, we can add 6 to both sides of this equation. So what we have left coming down here is 6 is equal to -6x. So if we divide by -6, we'll get -1 is equal to x. So our x-intercept should be -1, 0. And we're just going to try to verify what that is. Now, -1 is going to be between x equals -8, -3, and x equals 2 on the left side. And that's going to get, looks like it'll be kind of, I won't say half the way through. We could proportionalize it that's going to be what it is. So I'm going to box these in as our correct answers. Anyway, that's it with our exercise today. Here's a look at problem 20, similar type of problem. Good luck, and thanks for viewing.